Now dears, Unit 2 or structure of atom is the topic in chemistry we are going to deal with, and NCERT chemistry solutions is what we are offering in this episode. This is Shishir Mittal from Vyas Certification, Kota. Welcome to the wonderful world of chemistry. I must add, before starting atomic structure, I must add, this is a very fundamental chapter which actually talks about how what is the structure of matter or how matter actually is made. What is the importance of this chapter? Actually, on this chapter, foundations of entire chemistry rests. There are more chapters like thermodynamics, yes, but ultimately, structure of atom is one of the key chapters which helps us in understanding why matter behaves the way it does. In that sense, it's a very fundamental chapter. There are portions in which you will need to actually learn certain definitions, certain properties, and there are sections in which you're supposed to analyze, see properly what is the concept, understand it, grasp it, and apply that. In that sense, this chapter is very, very vivid. It contains both memory-based ideas and it also contains a lot of deep understanding ideas and concepts. And let us explore all these using NCERT questions as an excuse. Let's begin. Calculate the mass of electrons, calculate the number of electrons which will together weigh 1 gram. Now, in this question, please remember that it is assumed that you are aware of mass of electron is so much. It is otherwise regarded as a standard data and you are just supposed to take this, so much is the mass of an electron. So what would I say? I would say that 9.1094 into 10 raised to minus 31 kilogram is the mass of one electron, right? But I need 1 gram, right? So let me convert kilogram to grams. 9.1094 into 10 raised to minus 31 into 10 raised to 3 grams. This one contains 1 electron? Yes. This makes it how much? 10 raised to minus 31 into 10 raised to 3 is 10 raised to minus 31 plus 3, which is 10 raised to minus 28, right? So 9.1094 into 10 raised to minus 28 grams contains 1 electron. So 1 gram would contain how many electrons? This into this upon this. How? Ratio and proportion, 600, simple. So 1 into 1. It is not e to the power minus s. Sorry, don't misunderstand this. What I mean to write is electrons, nothing else. What do I need to do? Now I just have to do calculations. And how would I do that? This is a little mathematical portion. Let me again share with you a secret. A secret? Yes. And what is that secret? It's a calculation secret which says 1 upon 1 plus x is approximately 1 minus x. And 1 upon 1 minus x is approximately 1 plus x. If x is much, much less than 1. If there is a very small number being added or subtracted to 1, then 1 plus x, the reciprocal is approximately 1 minus x and vice versa. Now, I have borrowed this result from binomial theorem in maths. We have not studied that. It doesn't matter. It's a result from maths. Just take it. Fine. So, I could use this and calculate this dirty thing. I could say that this is 1 upon 0.91094 into 10 raised to minus 27. Yes, I'll take this calculation here and I'll write this is 10 raised to 27 divided by 1 minus some number. Can I just write down complement of this number? Yes, I believe I can. So that would be 0. Start from this 6, okay, and 0, 9, 8, and this should be 1, 0, 0. So 0.08906 into so much. And 1 upon 1 minus x is approximately 1 plus x. So this is approximately 1 plus 0.08 906 can be approximated as 1 into 10 raised to 27, which is 1.0891 into 10 raised to 27 plus 27. So many electrons must be present in 1 gram. I've done this with calculation because usually calculation is the problem. Let's check the accurate answer. 1.098 is the calculator answer, and 1.089, very close we have got, into 10 raised to 27. So I guess we have done a very good job even without using a calculator. Calculate the mass and charge of 1 mole of electrons. Now, this is very interesting. 1 mole of electrons. How much is 1 mole? 1 mole is 6.023 into 10 raised to 23 electrons. Right? What is the mass of 1 electron? Mass of 1 electron is 9.1 into 10 raised to minus 31 kg. Roughly, we just saw that, right? I mean, this is a constant, we can assume that. And therefore, mass of 1 mole electrons is 9.1 into 10 raised to minus 31 into 6.023 into 10 raised to 23. How lovely is that number? And what does that give me? If I just say 31 and 23, that makes it how much? And 9 6 would be 54. So this is 54.6, a little more than that, around 54.7 at best. 5.47 into 10 raised to 24 and 31 would make it 10 raised to minus 7 grams, or around 0.547 micrograms. Micro is 10 raised to minus 6. Let me remind you, micro is 10 raised to minus 6. So many micrograms. That's it. That is the mass of 1 mole of electrons, or this is the molar mass of electrons. Pretty small. Yes, we know that. Anything else? Yups. Let's see. What about charge of 1 mole electrons? Now, charge on 1 electron is 1.6 into 10 raised to minus 19 coulombs approximately. So, charge on 1 mole electrons, and charge on 1 mole electrons, it also has a special name. It is called 1 Faraday. It is in honor of a great scientist, Michael Faraday. So, we say this is 1 Faraday. We have not studied Faraday. Don't be afraid. It is just a name. Faraday is a dead man, and a very respected dead man. So don't be afraid of him. He's a very nice, very benevolent, and very superb scientist. One of the most respected scientists in the history of science. So charge on 1 mole of electrons, which is also called 1 Faraday, that would be equal to charge on 1 electron into Avogadro's number. Let's multiply that. How much is that? 16 3s are 48, 16 2s are 32, 36, 16 6 are 96. How lovely is that? Yes. So that would give me 9.64 approximately into 10 raised to how much? Well, 19 and 23, that makes it 4 coulombs. Well, 1, 2, 3, 4. Let's jump this. This is 96368 coulombs. Huge number. So this is the accurate value of 1 Faraday. Often people approximate it as 96500 coulombs also, but that is just an approximation. These are the charges and mass. These are the charge and mass carried by 1 mole of electrons. Calculator answers mass of 1 mole of electrons and mass of charge on 1 mole of electrons. Just let's compare 5.486 and 5.4 7, we are close by, not very ugly, है ना? And 9.647, 9.637, we are close by. Again, I would say beautiful it is.